What if we could know how much rice or wheat a farmer will harvest weeks before the crop is ready? This is becoming possible with satellite technology and artificial intelligence. Satellites can monitor crop growth, plant health, and field conditions from space. When this information is combined with weather data, soil conditions, and crop models, scientists can estimate the expected yield before harvest. This technology can help farmers, governments, and food organizations prepare better for the future. The result? Smarter decisions, better planning, and a more secure food supply. So, how do satellites actually see crops? Two important technologies are Sentinel-1 and Sentinel-2. Sentinel-1 uses radar signals to monitor fields even through clouds and during the night. It can provide valuable information about crop structure and field conditions. Sentinel-2 uses optical imagery to capture sunlight reflected from crops. This helps us observe crop color, vegetation, and growth. Scientists then use indicators like NDVI to measure crop greenness and health, and LAI or leaf area index to understand the amount of leaf cover in a field. Together, these satellite observations help monitor crop growth, detect stress, and support yield prediction before harvest. Satellite data can tell us much more than just what a field looks like. First, it helps us identify the crop area and understand how much land is planted with a particular crop. By observing the field over time, satellites can also track different growth stages from early development to maturity. They can detect crop stress caused by drought, pests, disease, or water shortages. And during extreme weather events, satellite imagery helps monitor the impact of floods and droughts across large areas. All this information helps farmers, governments, and researchers make better decisions and improve food security. Weather data plays a crucial role in predicting crop yields. Temperature affects how quickly crops grow and develop. Rainfall determines water availability, while too much or too little rain can lead to flooding or drought stress. Solar radiation provides the energy crops need for photosynthesis and growth. Humidity also matters because it influences water loss from plants and can affect the risk of diseases. When these weather factors are combined with satellite observations and crop models, scientists can better understand crop development and estimate yields before harvest. Now, this is where AI and crop models bring everything together. Satellite data tells us what is happening in the field, such as crop growth, vegetation health, and stress. Weather data tells us about the growing environment, including temperature, rainfall, solar radiation, and humidity. AI can analyze these large data sets and identify important patterns. Crop models then simulate how the crop may develop under these conditions. By combining all this information, scientists can estimate the expected yield weeks before harvest. This helps farmers, governments, and businesses make better decisions about food production and planning. This technology is already useful in the real world. Race yield forecasting can estimate production weeks before harvest, helping farmers and governments prepare better. Governments can use crop information for planning procurement, storage, and food distribution. It also supports food security by identifying possible production shortages early. For crop insurance, satellite data can help assess damage caused by droughts, floods, and other events. And by forecasting future crop production, businesses and policymakers can better understand supply, demand, and possible market price changes. From the field to the market, better data can lead to better decisions. India is one of the world's largest agricultural countries, and satellite-based crop monitoring can support many of its major crops. For rice, satellites can map paddy fields, track crop growth, and identify water stress. For wheat, satellite data can monitor crop condition, detect drought stress, and support yield forecasting. In cotton, remote sensing can help map crop areas and monitor crop health. For soybean, satellite imagery can track crop emergence, growth, and stress caused by drought or excess water. The same technology can also support maize, pulses, sugarcane, groundnut, mustard, and many other crops. By combining satellite data with weather information and AI models, India can improve crop monitoring, planning, food security, and agricultural decision making. Although satellite-based crop monitoring is powerful, it also has some limitations. First, cloud cover can block optical satellite images, making it difficult to observe crops clearly. Second, data quality matters. Poor resolution, missing data, or technical errors can affect the results. Another challenge is field-level variability. Even within the same field, crop condition can differ due to soil, water, pests, or management practices. That is why ground validation is important. Field observations help scientists compare satellite predictions with real conditions and improve the accuracy of crop monitoring and yield estimates. Imagine a future where AI monitors crops every single day. Satellites continuously track crop growth, plant health, moisture, and stress. AI then analyzes this information along with weather and field data to detect problems early. It could predict drought stress, pest risks, and even estimate the final harvest before farmers enter the field. This means faster decisions, better resource use, and more accurate harvest planning. The future of agriculture may be powered by a continuous partnership between satellites, AI, and farmers. Follow agri-tech explained for more such videos